Hello. Hello, hello. Sorry, I was running a little late. I was just finishing this project up. So if you tuned in the previous session, which was just a few hours ago, I only had 2 gears. I was just manifesting this. Let me get rid of this. Okay, so you can see all this wild mess. I wanted to demonstrate the use of rotational matrix. Gears. That's the first thing that came up in my mind. So I created an HDA that just creates this simple gear with some attributes of where the tooth is and where the center, well, the center I know, the tooth height and the base, and that allowed me to easily add one gear. Well, it generates the gear at this origin, then I'll feed in another gear, but these 2 wrangles will automatically calculate the polar coordinate of where I should position the second gear. So that makes the job a lot easier. Now, I don't want to mess this up because if I change this, everything in this chain is going to change. So let's copy this. Move over here. Okay. So these 2 wrangles is where the magic happens. And that's where I use polar coordinates and rotational matrix. Now, this guy over here, I haven't figured out a procedural way to determine where to place this orientation so that the teeth will not intersect. So this is manual. This one is manual. This part is where the polar coordinates is calculated. And this guy in the second wrangle. I need to figure out the radius. The radius between here. Let me draw this out. Radius between here to here, let me draw like this. Here to here, from the center of the gear to the head of the tooth. That radius plus the radius between the second gear, the radius of the second gear of the tooth head to the center point. Now you can see this part will overlap. So for this part, I just take the maximum of the 2 tooth heights. Whichever tooth has a higher height, I'll just take that one. Realistically, I don't really need to even care about that because all the gears are the same size in this example. But if I were to make this gearbox generator a little bit more fancy, I would automate that. So, now one thing I can talk about is the polar coordinate. That is really interesting. That determines where I place the second gear. So let's take this guy. You can see that this guy goes around the first gear. Okay, this is a mess, but it's taking this input. This is the input feeding into it, telling where to place the where to calculate the polar coordinate, where to rotate around. So if I were to position input this to the second gear, it's going to rotate around. It's going to find, it's finding the polar coordinate of the radius of these 2 lines that I was talking, these 2 blue lines that I was talking about. So let's look at what mess I have created here. So this is the angle, and that's just this guy over here. And that's choosing like which polar coordinate to use. It doesn't matter as long as I have one of them. For this simplistic HDA. I mean, if I wanted to procedurally create the entire gear, like instead of having this train wreck here, and just have one node, because really, realistically, I'm stacking the gears on top of each other, but I'm automating the tedious parts of it, like choosing the polar coordinate part. So it makes it really easy to create that train wreck. So this is the angle or position on the polar coordinate that you want. Then we have this funny looking little thing here. Row 1, row 2. I'm really I'm creating a rotational matrix. A 2x2 rotational matrix. Here I'm converting the 2x2 into a 3x3 because Houdini's 3D, so I can't deal with 2D. Now this is the part where you might find this more familiar. Row 1 is cos, sine, and the second one is sine, cos. Now, doesn't that look familiar to you? Remember this guy from one of the previous lessons? I'm going to hook this up here. I'm going to get rid of the template. I'm going to get rid of that line. You did a sine, $sine f. Cos, $sine f. Okay, let me speed this up a bit. Yeah. So it's that. Now you might be thinking, hey, this is not rotating on the spot. Well, it's rotating in a circular motion in the polar coordinates. It's actually traveling along the polar coordinate of this guy. So if we were to draw a circle line here, it's actually traveling along the polar coordinate of him. But the radius is off because this is of unit 1. You can fix it by like multiplying something to this, like to make it longer. Like I go like 2 here and then 2 here. So it's a larger, it's rotating, pivoting on a larger radius. But I'm hard coding this. I'm not getting any information from this gear. I'm just hard coding this travel point. What I wanted to show you was that this formula here. Let me pop this out. This guy here is very similar to what we have here, which is the polar coordinate. This is actually a rotation matrix. The polar coordinate. Oh, this one. Oh, I just copied the wrong angle. Sorry. Okay. Polar coordinate is here. This is the polar coordinate formula. The other one, this is rotating. This is a rotation matrix, which is making it spin. This is the polar coordinate. And this is what I was trying to show you. Sorry, I clicked on the wrong one. Pop this out. Get a little thick and I'll just highlight this. So this polar coordinate looks very familiar. It looks very similar to this. It's because it's sort of derived the same way using the same right hand triangle trigonometry rules. Well, they all are, but this is very, very similar. So as long as you know the radius of the circle that you want to travel on the polar coordinate, if that makes sense, which is like the circular animation path that I showed you. As long as you know the radius of that, you can calculate the polar coordinate of the XY. Say, I want an exact position on that circular path. I want to know that because, I don't know, if it reaches a certain you're implementing a collision detection in your game or something, and you want to know if it hits some particular objects, you're doing collision detection, so you have to know the polar coordinate if you're doing a circular animation. Or in this case, I'm using it to position these gears. That's when it comes in handy, when you want to know the exact position on a circle. All you need to know is the angle, which is controlled by this manually. I'm just choosing the angle. If you don't know what the angle is, just make it 0. Then it'll just be like the initial state. And then, as I mentioned, the radius is calculated from the center of the gear to the tooth, the head of the tooth, and to the other gear center combined together. Or in your case, if you just want to rotate the polar coordinate of a single circle, then you just need the radius of the circle. Then you just multiply the cos, angle, and like the formula is very similar to this guy. Is that we don't use frame because the frame is driving it for the animation. Instead, you're going to substitute the frame with the angle. Don't forget to convert the radians. And the radius becomes that scale. That's the scale that I was showing you, the ×2, to make it longer or shorter. Well, you don't know how far. Well, we do because we know the radius of the circle. Well, you have to know the radius of the circle. If you don't have that, I don't know if you can calculate the polar coordinate. So yeah, based on that, I create this monstrosity gearbox. And they're all rotating using this the rotational matrix. Using that same offset. I hope that this part looks familiar because that's what we just talked about just a few hours ago. Oh. So that's that offset. Hopefully that looks familiar. So it's grabbing the center of the gear, and that so happens to be the distance, and then applying the rotational matrix because the rotational matrix only, if you want to rotate in place, it only works on the origin. You have to offset it to the origin, apply the matrix, and then offset it back. Cool. This will make it rotate, and as I said, the polar coordinate is what I used to position the gears, to help me position the gears. I mean, there's still a lot of manual work in there. They kind of look like a bunch of flower gears. Yeah, they're not very straight. I wish I had more time to like finesse this, but that's why I was late. Because if you were tuning into the previous session, I only had 2 gears or 3 gears, and I was manifesting it. One of the neat thing is, even if it was done manually, it's not too bad because once you get here, this guy, you can actually copy it. Let me template this and then transform and just manually position over here. And actually here, I can do one. So it's not too bad because a lot of the stuff is already like it's already automated. let me position this. So once I had most of the gears going, now I don't know which direction this guy is going, so I have to actually test it. Oh, I should just template it. Connect it. Okay, so this is not working. Let me see if I can show you a better view. So you can see that they're overlapping. That's not going to work, so let me just pick this gear. No, let's see. If I pick this one, or let me pick this one. If I put this one over here, it would work. So this is the part where it gets not as elegant because this part isn't automated. Oh, let me stop it. Nope. Wait, isn't this the one that was rotating? Which one was it? One of them must rotate. Let's see, this goes this way, that goes that way. I need to find something that goes this way. That goes this way. Okay, this one, but that's okay. Let me rotate it like this. Okay, I think I found one. I think I forgot which one it was already. Yeah, this part is the most tricky part. Because when you have a lot of them. Okay, yeah. And then I've added a branch. To add a single one, so I would do this. Now I had to find the reference vector, reference gear to add it on. Let me put this here and this here. Now let me choose a reference gear. Which one this is? That's that one. Okay, so let's just use that's in the middle. We're all in the middle. I've surrounded them. I need one that sticks out because I can't reach the ones that are in the middle. Oh, they're all surrounding inside. Okay, this one I'll have to do. I'll just have to position it carefully. It was much easier before I started putting the transforms. Once you put that down, it's a lot harder. Ugh. Let me put this and template that. Oh, and I have to see the rest of them too. Right, control. Yeah. So this would go here. So this makes it a lot easier because I just have to adjust this slider so that it's like in the middle. And it doesn't matter if it's overlapping because I can adjust the rotate. But this part is manual, so that kind of sucks. Let's see if the rotation works. So this one is not correct. I should really pick another one. What is driving? How am I determining which direction each gear is rotating? Is just by this for loop. It really is just taking every other gear is turning the other way. That's all. That's really all it's doing. So I'm taking the modulus 2, which is every other gear. So every gear gets an ID. It gets iterated through. So it has an iteration ID. So I'm taking every even number or every odd number and then I'm rotating that counterclockwise. However, because I've already manifested this, like, this gearbox sort of thing, I've lost track of which one is the odd and even one. So let's... And I'm running out of room too, because they're all being covered. Yeah, so this is right in the middle, like it's being covered. I don't have access to these guys anymore. The reason is I want to choose one from these and not one from the gearbox that's already here, is because the information I embedded in each gear of the tooth height and base height is all in the detail of each gear. Now, details, once you merge it together, that it just picks one of them and then slaps it on. So I lose all that data. I really should have stored this on the points or maybe primitives, and then I could add this on any other one. Oh well. So hopefully, so I'm gonna make this HDA available for, again, yeah, for the perk members. So this is just a quick demonstration of what you can do with rotational matrix and polar coordinates. Okay. Hope you enjoy.